Hey everyone, welcome back to the IT Classroom. My name is Donovan, and today we're going to cover switching. We're going to start with layer 2, and then I will do another episode on layer 3 afterwards. So let's begin. In this setup, we have three machines. We have a PC up top, a laptop on the bottom, and a server on the right. The server and PC are in the same subnet, 192.168.0.1 and 192.168.0.2. So the network portion is 192.168.0 for both of these. And the laptop is in 192.168.1.1 subnet network. So by default, these cannot talk to each other. And today I'll kind of show you how layer 2 switches learn communication and how we can actually get these two different networks to talk to one another. So I've already pre-configured the IP addresses on these. So let's go ahead and add a switch here. We're going to use a layer 2 switch. Is going to be the 2960. We'll click on this. First thing we're going to do is let this run. I can see if I could speed this up. There's actually kind of a cool little thing here. So we'll speed that up a little bit and see if that worked. Yep. So I'll do enable, and there's a quick command to see what the MAC addresses are. So the way layer 2 works is with the data layer, which is all on MAC addresses. So we could do show MAC address table, and that's going to show us what the switch knows. So right now it doesn't know anything. So let's go through and see what happens when we add some connections. For this, I use a copper straight through for each one of them, and I'm just going to keep plugging into the first usable port, both on the PCs and on the switch. Perfect. If I open up PC1 over here, and let me expand this a little bit. I'm going to run a command here, and I'm going to run two commands. One, an ipconfig /all, so you can see what this MAC address is. This MAC address ends in A850. And if I do another command, just like I ran a command on the switch, machines have their own command to know what their own MAC address tables are and what they've learned. So if I do ARP-A, it says no ARP entries found. So that means it doesn't know any MAC addresses right now. So let's see how the switch actually learns it and how the PC can learn it. So we're going to do a ping from our PC on the top left here, 0.1, to our server on the right, 0.2. And we're going to see what it looks like for the switch to learn this and for the PCs to store those addresses as well. So we're on a simple ping to 192.168.0.2. That's our server. I'm going to switch over to simulation so we can see this as it goes. I'm going to hit enter, and we'll start the simulation. First thing we're going to see is the packet goes to the switch. The switch doesn't know any MAC addresses, and it doesn't know any IP addresses, so it's going to send a broadcast to all other devices on the network, and we'll see that here. This time, the bottom PC, the laptop on a different network, drops the packet because it doesn't know who 192.168.0.2 is, so it just drops it. The server, on the other hand, we're going to see it respond because it's telling the switch, that's me. And then the switch is going to send it back to where it came from. And it knows where it came from because of the MAC address. So now, let's take a look at our switch and see what MAC addresses that it knows. So again, we'll do show MAC address table. And now it knows two MAC addresses. It knows our A850, which is on Ethernet, Fast Ethernet 01, and it knows 199 or 1933, which is on Fast Ethernet 03. If I were to pull the server back up and go to the command prompt and type in ipconfig/all, we can see that ends in 1933, so that matches up. If I go back to the first PC here and I rerun that command I ran in the first place, which was arp-a, now all of a sudden it sees that 192.168.0.2 belongs to 1933. So now I'm going to restart the simulation, and I'm going to send another packet directly to 192.0.2, and the switch, instead of doing that broadcast, it will know how to get to 192.168.0.2. The way that this works is the packet or the frame that's coming from PC1 is encapsulating the IP address. So it sends the information at layer 2, so a frame, to the switch with the MAC address. The MAC address is saved in both the PC and the switch. The switch sends it directly to the server. It decapsulates the packet or the frame and sees that it's looking for 192.168.0.2, which matches this IP address. So now it can communicate on layer 3. So let's see what that looks like. Go here. We're going to rerun our ping. Hit enter. When I see the packet leave PC1, so I go back to the switch. And this time, when I see it go directly to the server knows who it is and knows that it was destined for it, so it sends it back, and the switch sends it to the original client. Okay? So that's working. What if I try to talk to 192.168.1.1? If I do a ping, this is from PC1, I'll restart my simulation, and I do ping 192.168.1.1. So I'm trying to go to this laptop on a different network and hit enter. We're going to see something similar where the switch is going to send out a broadcast because it doesn't know who that MAC address is or that IP. But this time, both of them are dropping it. And the reason they're both dropping it, even though this IP address is correct, is because by default, a layer 2 switch can't talk to different networks. So how do we fix that? We have a concept called router on a stick. And what that is I'm going to add a router into this device or into this topology. And let me just grab one. I believe this one should work pretty well. So we have to configure something called a VLAN. We haven't really spoke about VLANs up to this point, but what a VLAN does is it allows you to use the interface and you break it up into kind of sub interfaces. So it's still one port, but you have these sub interfaces on that port. So you're breaking it up to do more than just one communication. So when PC up here talks to the switch, it's going from one Ethernet port to an Ethernet port on the switch. It's dedicated to that. For a router and VLANs, what we need to do is we need to make a connection here. Same cable, but this time we're going to use gigabit Ethernet 01, and we're going to do the same on here. This is not the router I wanted to use, so let me see if I can find a different one real fast. All right, we're going to go back to our network devices. I'm just going to pick one. This can work with any of them, but some for tutorial purposes are just a little bit easier to set up than others. So I'm just trying to find one real quick that will be a little more straightforward for this course's purpose. So let's do 1941 here. And we'll go back to what we were doing, which is the straight through. I'm going to go to Gigabyte Ethernet 01. And on here, I'm going to do Gigabit Ethernet 01 as well. So I'm just saying keep the Ethernets the exact same. And now I'm going to run a few commands on the switch and a few commands on the router. I could do a lesson on Cisco. I do have my Cisco CCNA. Admittedly, it's been a while since I've had to use it, but I'm more than happy to do more classes on Cisco and routing like this. Should you want it. So let's go ahead and get started with these commands here. So on the switch, I'm going to do a command called enable. I'm already in there, and then I'm going to do configure terminal. So what I'm doing before I even get started is I have to make two separate VLANs. A VLAN is simply just separating networks with kind of this logical programming that we're doing on the switch. And then how it works is we are going to define a default route, sending our traffic to our router. And the router with our commands is going to know that 0.1 is going to live on, let's say, VLAN 10, and 1.1 is going to live on VLAN 20. And you can make those numbers anything you want. You just have to make note of them so you don't lose it. And then the router can send it to the right place. And I'll show you what it entails to do that. So we'll stick with those VLAN 10 and 20s. So I'm going to do VLAN 10, and I'm going to name it IT VLAN 1. And then I'm going to exit. I'm going to do VLAN 20, and then name that IT VLAN 2, and exit. So now all I've done is I've created two VLANs, 110, and I've named it IT VLAN 1 and IT VLAN 2 for the 20. That doesn't do anything with our PCs yet. Now we have to do another step, which is actually telling our switch where to send traffic for these VLANs. So what we'll do here is we will configure our gigabit Ethernet port that we configured, which was 01. So we'll do interface gigabit Ethernet 0/1, and we're going to say switch port mode trunk. Trunk is what enables VLAN to go through to the router here. And then we're going to give it a description called trunk to router, and we'll exit there. Okay. Now, we still haven't told these PCs to use the VLAN yet, so that's the last thing that we have to do on the switch side. So we'll see what that looks like real quick. So we're going to say interface fast. We're actually going to do a range. So I'm going to select both of these so we can see what ports these are. So this is fast Ethernet 01 going to the switch, and fast Ethernet 03 going to the switch. So with that, we could say interface range fast Ethernet 0/1, comma 0 fast Ethernet 0/3. Those are the two that we're concerned about. And for that range, we're going to do switch mode access. And we're going to do switch port access VLAN 10, because we want to assign that to that first VLAN, IT VLAN 1 that we made up here, which lives on VLAN 10. We're going to exit here, and we're going to do the same thing on our laptop down here, which is on fast Ethernet 02. So let's go to interface fast Ethernet 0/2. We're going to do switch mode access, switch port access VLAN 20, because we want to assign it to IT VLAN 2. We'll hit enter. And then we could go ahead and exit out of here. Okay, so let's take a break and talk about what we did. We first set up the VLANs up top here. We set up a VLAN 10 named IT VLAN 1. Then we set up VLAN 20 with the name IT VLAN 2. These are our two separate networks that we're concerned about. Then we had to set up the trunk, which is just a VLAN term that tells the switch where it should be sending the VLAN traffic to. So we told it to go out of gigabit Ethernet 01. So if you're trying to talk with VLAN, you should go out here. And we want to talk to our router. We haven't configured the router yet. We're all just on the switch. Once we had the port that we know that the VLAN traffic should travel out of for routing, then we say let's assign these machines to their appropriate VLAN. So for 10, we did 0.1 and 0.2. And then for VLAN 20, we did 1.1. Okay, so we're done with the switch here, which is great. Let's go into the router, and we're going to do a similar configuration over here. We need to tell the router to expect these VLANs to come in and how to route them once they're in. So I'll go to the command line here. Here, I'm going to speed that process up and go back and see if this router is ready for us. No, I don't want the internal. And we'll do enable. Enable always gets you into the configuration mode. Then we can go ahead and start configuring the router to expect this traffic. So let's go ahead and see what that looks like. So first thing we're going to do is configure the interface for that's connecting to the router. That was also gigabit Ethernet 01. So we're going to do interface. We're going to do configure. We're going to do configure terminal. Then configure interface. And then interface gigabit 0/1. And we're going to do no shutdown. That's telling that port to always stay up and alive. And then when that exit, and the reason we want to keep that port always up and alive is because it's expecting VLAN traffic now. So we need it to be able to talk to this at all times. So let's go ahead and start configuring the actual commands to set up our VLANs on the router side. So we're going to go, we're going to start with VLAN 10, and we'll do interface gigabit 0/1. Now this is the key part here, .10. So this is where making the sub interfaces come in. And we'll actually see that if I hit enter, it says sub if right here. That means we're on a sub interface, okay? Once we're on the sub interface, we could go ahead and encapsulate using .1Q. That's a VLAN type of encapsulation. And we're going to say 10 for VLAN 10. And we're going to give an IP address. And this IP address is going to fall within the range that we're talking about on the VLAN that we want. It's going to be the last usable, it'll be the last usable IP address. So we're going to do 192.168.0.254 with the subnet mask of the same on the machines, which is 255.255.255.0. If you're not familiar with subnetting or IP addresses, go check out my last video on how to do this, and I break it down so you can know everything about subnetting, so this won't surprise you going forward. We'll hit enter, and we can exit out of there. Then we're going to do the same thing for our second VLAN, which is going to be interface gigabit 0/1.20 for our VLAN 20. And we're going to run a very similar command here with encapsulate. I'm going to do .1Q for VLAN 20. And then give it the last usable IP address with the same subnet mask. Oops. Let's see. I think I actually have to put IP address in front of this. Okay, then we can exit. And I believe that's it. I think we could just send traffic now. So let's see if this actually works. We'll open this back up, and we're just going to run ping to 1.1 again and see what the traffic does. I reset the simulator, and we'll just hit enter. I'm actually going to do this in real time, just because it can be a little bit slow. So let's go to real time here and see if we get responses. So the first one timed out. I'm expecting the second one to go through. The first one is probably learning the ARP addresses. So let's see if it starts responding. So all four failed, which is not what we want. I'm gonna run it one more time just to see if maybe there was some sort of delay in the packets. There we go. and now we can see it's responding. So sometimes when you do these configs, it can take a second for the switch and router to learn them. So it's important to be patient. A lot of times when you see like these first errors, even someone like me who's been in IT for over a decade now, like when I still see request timeouts, I immediately think I configured something wrong, especially when I'm doing a tutorial where I haven't worked with configuring Cisco routers and switches, you know, recently. It's very easy to start worrying and immediately want to go check your configuration. But a lot of times it just takes a little bit for the routers and switches to work. And now going forward, it's just working every time. If we go to our MAC address table on the machine here. So now we can see that it knows our gateway address of 0.254. So if I click on this and actually click out and go to our IP config, I had defined our default gateway earlier. I wanted to show you that inside of this, but you have to define the default gateway. So the way that the default gateway works is if it can't find anyone, it doesn't know about them, like 1.1, it doesn't know about that IP address. It's telling it go to this router. And this is the sub interface we configured with that IP address. So that's how it knows to get there. And same thing for the laptop. The laptop, if it wants to talk to 0.1 or 0.2, we would have to configure the same thing, which I already did. I give it the 192.168.1.254. So it knows that if you're trying to talk to 0.1, it's not going to live on my network. Go to the router, and the router can figure it out with the VLANs to send it to the proper machines. So that's how layer 2 switches work. They just operate solely at a MAC address level. They depend on encapsulation from the machines to have the correct IP and information. So when they send it to the target machine, it knows what to do with it. If you want to talk to different networks inside of a layer 2 switch, you need to do a router on a stick method like this, where essentially the traffic goes to the switch sends it to the router can make routing decisions, sees that's on another VLAN, and sends it to the appropriate destination. In the next video, I'm going to cover layer 3 switching and how it's different and how we can actually remove the router from the picture altogether. As always, if you like this, please subscribe. I really do this for the viewers and to give back. I would love to just spread awareness of this and make videos that you, the viewers, want to watch. It means a lot to me that you take time to watch these. If you have any feedback on them, please let me know. If there's something I covered too fast or don't cover in depth enough, leave that in the comments, and I can always go back and elaborate on any of these topics I cover. So again, thank you, and I hope this was helpful.